Hi everybody, this is Mrs. Logus and I'll be taking you through Unit 12.0, which is all about conic sections. And conic sections are really pieces of these double, I guess technically these are called double napped cones, but it's whenever you take a plane and you intersect one of these double cones, it creates one of these four conic sections, either a circle, which you're familiar with, a parabola, which you're more familiar with, an ellipse, or a hyperbola. And so a conic section is really formed when a plane intersects a cone. And if you're interested, I found this link on YouTube that I'll put in this video, also on Schoology and also in every video to come. This link that shows you where these conic sections come from in a 3D manner and also on a coordinate plane. So actually we have a video within a video. Wow, that's very Matrix-like. Top-notch movie, don't you think? I sure think so. Anywho, back to conic sections. If I click on this handy-dandy link here, please let me do it. Come on. There we go. So if I click on this link, I want to show you that someone made this beautiful YouTube video that shows you in a 3D way. For instance, if I go to a circle, this is the plane that's perpendicular to this shape, and this is how a circle is really formed. This perpendicular plane goes downwards and creates a bigger and bigger circle on your coordinate plane here, and it can go up as well. Not only does this video do this for circles, it also does it for an ellipse, it does it for a hyperbola, and a parabola as well. So please keep this video in the back of your mind as we go through the videos here. So if I go back here, let's first look at the geometry definition of a circle. A circle is the set of all points equidistant or the same distance from a fixed point. So if I have a plane and I have a point, the fixed point called the center, if I move the same distance away from that point, I form a circle. So all of these points here you would say are equidistant from the center, or all of these points are the same distance away, which we have called the radius. So feel free at this point, if you'd like to answer this next question, what do I already know or remember about circles? You can think back to geometry last year. You can even think back to earlier this year. In the first couple weeks of school, I already made a video about circles. Fun fact, actually. So feel free to pause now and write down what you know. If you're having a hard time remembering some things, don't worry, I have your back here. Let's remember that the standard form for a circle, and from an analytic geometry perspective or from the cone and plane perspective, is this formula, where h comma k is your center, the radius is r, and in the equation, the radius is squared. So if I had this formula, the signs here are always opposite of what you see in the equation. So the center here is really -3, 1, because the formula is x minus h. To get to be a positive 3, it originally had to be x minus -3, which is why the center is at -3, 1. The radius in the equation is r squared, which means that r must be the square root of 25, or 5 units. And graphing a circle isn't too bad, because I would start with the center, -3, 1. And because a circle is defined as equidistant from this center or fixed point, I would go this distance in every direction. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and finally 1, 2, 3, 4, 5. And this is when I stink at drawing. Drawing these circles this way is easier said than done. Not terrible, but definitely not the best circle I could have drawn. But the main thing is just to make sure that you have that radius of 5 all the way around. So before we move to the next example, I would like to look at this box here, and this is a general second degree equation, highest power of 2, and what makes this equation a circle specifically? Well, everything really has to do with the squared terms. So if this equation is a circle, the way you can know that quickly, if it's not in this vertex standard form here where you can see the center, is if the A term equals the B term, so it has the same value and the same sign, both positive or both negative. You also instead of value could say same coefficient also. So an equation, if it's not in standard form here, is a circle if A and B are the same value and they have the same sign. This will help us because, of course, I have an example that's not in standard form. I mean, what kind of video would this be if I didn't provide you one of these where we have to complete the square? Isn't this the best day of your life that we get to complete the square here? So what we get to do is, in order to complete the square, we do eventually need a lead coefficient of 1. And so we need this to eventually look like this equation. So we need to get parentheses. Also, before I start, notice that the two squared terms have the same value and have the same sign. So I know it has to be a circle. Here's what I would do to complete the square in order to get this to look like the original circle formula, the standard form. We do want to complete the square because that's one way we can get parentheses. So the first thing I'm going to do is rearrange this. I'm going to put the x's together, I'm going to put the y's together, and I'm going to move the 17 to the other side by subtracting it. So we don't want it there. I now need to begin my process of getting a lead coefficient of 1 so I can complete the square. So I'm going to look at my x terms. I'm going to take out a GCF of 9, and I'd be left with x squared plus 6x. Because I have a b term here and I want to complete the square, I have to add a blank here so that I can complete the square soon. And I'm going to do the same thing for the y terms. I'm going to take out my GCF of 9 and be left with y squared minus 4y plus blank equals negative 17. Because I have two blanks over here, I need to add those blanks over here as well. Now here's where you just need to be careful. To complete the square, to get that blank, it's b over 2 squared. So 6 over 2 squared is 9, and negative 4 divided by 2 squared is 4. So I wouldn't just add 9 over here. I would add 9 times 9, or 81. And here I'd not just add 4, but add 9 times 4, or 36 over here. If I continue completing the square, this becomes x plus 3 quantity squared, and this becomes y minus 2 quantity squared equals negative 17 plus 81 plus 36 gives me a nice answer of 100. Now, if you notice back on the previous example, we did not have any coefficients in front of the parentheses. So what I'm going to have to do is divide everything by 9 because we want nothing in front of those parentheses. So I'd have x plus 3 squared plus y minus 2 squared equals 100 over 9. So this would be my answer in standard form, but it also asks to identify the key components. And the key components of a circle are the center, which would be at negative 3, 2, and my radius. How convenient, but that both of these are perfect squares, so my radius would be 10/3. Not bad. So what I'd like you to do is try this next example the same way that we did number 3. As a suggestion, I would move the 6 over first. I would get my x's together, get my y's together, and then take out a greatest common factor. For the x's, you're going to have to take out a negative 3, so be careful with your signs. So please use the previous example as a guide and try this one on your own, and I will come back with my work. Please pause now. Quick check-in point. Did you take out a negative 3? And if you did, you are left with a negative 2 here. Did you take out another negative 3 here? And were you left with a positive 4? Please be careful. When you negative divided by negative, you got a positive there. All right. Please pause again. Just want to do a brief check-in. Another check-in. When you did b over 2 squared, please make sure you got 1 here. Please make sure you got 4 here. And make sure you added negative 3 on this side, because negative times positive, and negative 12 on that side. All right, I'm going to pause again. Please do so as well. All right, so after that step, I completed the square and got x minus 1 squared, y plus 2 squared. I notice now that I have these negative 3's in front, so I'm going to divide everything by negative 3. And so if I do that, I would get x minus 1 squared, now plus negative divided by negative, y plus 2 squared equals positive 3. Yay, we got rid of the negative over here. That's lovely. This looks now that is in standard form. So my center is at 1, -2, and my radius, if this is really r squared, that means that my radius is going to be the square root of 3. Feel free to pause and watch that again if you need to, but this idea of completing the square is going to be useful in every video to come. Last but not least, find the equation of a circle that has a center of 3, -5 and a point on the circle of 5, -3. So there are multiple ways to do this question. I'm visual, so sometimes I like to draw a picture. My center is at 3, -5, and I have a point on the circle at 5, -3. So that means that from the center to here would be my radius, and so my circle would, this is not perfect, but it probably looks something like that. Not bad, actually. Not a bad circle. So my circle is going to look something like that, and I need to find the equation of that. So I eventually need to have something in this format. So what we could do is we could use the distance formula to find this radius, but I'm thinking because we know this point, and the center is really h, k, and because I know this point on the circle, so all points are really x, y, why don't we just plug in what we know, find the radius, and then answer our question? So my x value is 5, my h value is 3, so we have 5 minus 3 squared, plus the y value is -3, the k value is -5. So be careful, it should be minus -5 squared equals r squared. So this really becomes a plus. So I have 2 squared plus another 2 squared equals r squared. 4 plus 4 equals r squared. So r is 8. Now, good news about finding the equation. I don't really care what the radius is. I only care that r squared is equal to 8. So I can actually answer my question right now. Because if you look back at the very first example we did, notice that the standard form only cares about h, k, and r. So if I go back, my equation would be thus. X minus h, which is 3, squared, plus y minus, the k is -5, squared, equals r squared, which is 8. So x minus 3 squared plus y plus 5 squared equals 8. That is my final answer for the standard form of this circle. And again, it doesn't matter. You could have, absolutely, you could have used the distance formula with 3, -5 and 5, -3. You could have used the distance formula, this thing, to find that distance, and then you could have used that radius and plugged it into the equation, but you would have gotten the same answer anyway. I know I remember from earlier in the year, many of you actually preferred this way over the distance formula. All right, guys, that's the good reminder of circles. Please make sure you're okay with the middle 2 examples of completing the square, because it is not going to go away in the videos to come. All right, guys, I'll see you in the next video about ellipses.